6.4, number 10. If $88,000 is invested in an annuity that earns 5.8% compounded quarterly, what payments will it provide at the end of each quarter for the next 5.5 years? Okay, so it's an ordinary annuity because it's paying at the end. We're investing it now, and then it's making payments, so that's a present value. We know the present value is $88,000. The question is asking for what the payments are, so we don't know that. What's the frequency or compounding? So it's quarterly. So that means, 1/4 and 4. Our time frame is 5.5 years. So we want that as a decimal, and then we have to figure out the period. Number of periods. And the interest rate is 5.8%. Again, that's annual, and so we have to adjust it for the period. So the interest is 0.058. So then we have to divide that by 4 to give 1.45%. Again, as a decimal. We have 5.5 years compounded quarterly, so we're going to have 5.5 times 4 to give us 22. And we need to find the payment. So we have present value, and it's an ordinary. So this is our formula. Again, the growth factors. So we know present value, we know the interest rate, we know the period. We're trying to find R, the payment. So R is going to equal the amount, the lump sum invested, divided by this growth factor. Okay, and so now we plug this in, compute what this growth factor is, and then divide the lump sum by that. See how much the payments it can make for 22 quarters. So we have 88,000 divided by 1 minus 1 plus 0.145 to the negative 22. Okay, so I'm just going to focus on this growth factor here for the time being. So that's going to be 1 minus 1.0145 to the negative 22 divided by the period interest. That needs another 0. So 1.145 raised to the negative 22nd. Again, because this is a negative power, this number here is going to get smaller. So we get about 0.72. So 0.27 divided by 0.0145, and then we're going to divide that result, divide the total invested by that amount, so divided by 0.0145. So that gives us a growth factor of about 18.72. So coming back here, you have 88,000 divided by 18.72. That gives us 4,700 approximately. And at this stage, you now want to round, so you have 4,700 and 85 dollars. So that's your final answer there. Okay, so if you don't round, in the internal calculation I dropped these digits and I came out with this number, and it really should be slightly less. So it really should have been 4,755 cents there. So just dropping these digits has an effect on this tail line, and what that means is you'll miss the desired, your payment's actually slightly higher, or you'll miss the desired payment that you're trying to structure if you don't account for all the digits.